Chapter 4.1 and 4.2 meshed together here is going to be exponents and the rules for combining exponents, essentially. So there's going to be a whole bunch of rules here. So starting with the product rule. So if we're multiplying two factors where they have the same base, in this case base b, with different exponents, to combine them into one base, we would add the exponents. So multiplying common bases, you add the exponents. So to see why this is, let's say we had b squared times b cubed. So whatever b represents here, just a number. B squared is b times b. B cubed is b times b times b. So we have 5 b's being multiplied here, right? So this is going to be b to the 5th power. So we just showed that b squared times b cubed equals b to the 2 plus 3, which is b to the 5th. So we can see kind of why it is that why we add them to combine them into one. So let's do some examples. So multiply each expression using this product rule. First one, x squared times x cubed. So they're the same base x. So we're going to combine them by adding x to the 2 plus 3, which is x to the 5th. Okay, and then the next one we have y cubed times y to the 4th. So they're all base y. So we're going to add all of these exponents. So it's going to be 3. There is a 1 exponent if it's not written. 3 plus 1 plus 4, which is going to give us y to the 8th. And make it a little bit harder here. So we have, for the next one, 6x to the 4th y cubed times 5x squared y to the 7th. So we have multiple variables here and we have coefficients. Multiplying the coefficients, 6 times 5 is 30. For the x factors, x to the 4th times x squared, add their exponents. For the y factor, y cubed times y to the 7th, add the exponents. So we get 30x to the 6th, y to the 10th. Okay, and next one. Negative 2x y squared z cubed times 4x to the 4th z to the 16th y to the 8th. Once again, let's multiply the numbers. So negative 2 times 4 is negative 8. And then we have x, y, and z factors here. So x to the 1st times x to the 4th. We're going to add the exponents, 1 plus 4. For the y term, or the y factor, y squared times y to the 8th. Add the exponents, times z to the 3rd, and then z to the 16th. We add them again, so 3 plus 16. So it's negative 8, x to the 5th, y to the 10th, z to the 19th. Okay, so that's the product rule. Next one is the quotient rule. So for the quotient rule, it's pretty similar to the product rule. If we're dividing b to the m divided by b to the n, to combine them into one base, we subtract. So it's going to be b to the m minus n. The exponent in the numerator minus the exponent in the denominator gives us the new exponent. So getting an idea of why this is, let's say we had b to the 5th divided by b squared. B to the 5th is 5 b's being multiplied. B squared is b times b. So 2 b's in the numerator and denominator are going to cancel each other out. And then we're left with b times b times b, which is b cubed. So we just showed that b to the 5th over b squared equals b to the 5 minus 2, which is b to the 3rd. Okay, so let's do these examples down here. So let's divide each expression using the quotient rule. First one, x to the 6th divided by x squared. So they have the same base, so we can combine them. So we subtract, it's going to be x to the 6 minus 2, which is x to the 4th. And then we're done with that one. Pretty simple. Next one, we have y to the 15th divided by y to the 4th. we combine them in the same base by subtracting their exponents, y to the 15 minus 4, which is y to the 11th. Next one, negative 3 to the 6th divided by negative 3 to the 2nd. So common base of negative 3, subtract the exponents, 6 minus 2. That's negative 3 to the 4th. And a little bit more complicated with this last one here. Once again, we have 30 x to the 12th, y to the 9th, divided by 5x cubed, y to the 7th. So 30 divided by 5 is 6. X to the 12th divided by x cubed, subtract the exponents, times y to the 9th over y to the 7th. We're going to subtract the exponents, so 9 minus 7. So we get 6x to the 9th, y squared. And for the next rule, it is the zeros as an exponent rule. So I believe we already know what this is, but let's go over it again. Anything raised to the 0 power equals 1. So b to the 0 equals 1. So let's see why using a couple of the rules that we've already done. Well, one of the rules. Let's say we had b cubed over b cubed. Based on the quotient rule, we know this is b to the 3 minus 3, which is b to the 0. Or we could have said b cubed over b cubed is b times b times b over b times b times b. All of those b's cancel out. 3 in the numerator, 3 in the denominator, and it equals 1 over 1, which is just 1. So since both of these started with b cubed over b cubed, and we got two different answers, that means this answer has to equal this one, which means b to the 0 has to equal 1, because they both equal b to the 3rd over b to the 3rd. So let's do a couple of these examples. For the first one, we have 8 to the 0. So this one's pretty simple. Anything to the 0 equals 1. Next one, we have negative 6 to the 0. Once again, pretty simple. The whole thing is raised to the 0 power. So that's just equal to 1 again. Then 5x to the 0. That whole thing is raised to the 0, so it's 1. So now we have to start being a little bit careful in these next ones. We have negative 4 to the 0. That is not in parentheses. It's not negative 4 all to the 0. It's negative and then 4 to the 0. So what this means is negative 4 to the 0, which is negative, and then 4 to the 0 is 1. So that whole thing is negative 1. So it's like negative 1 times 4 to the 0. Same idea with this next one. We have 3y to the 0. Only the y has the exponent of 0. So this is 3 times y to the 0. So that's 3 times 1, so it's 3. Next one, negative 3x squared, y times z to the 0. The only thing being raised to the 0 is y times z. So this is going to be negative 3x squared times 1, which is negative 3x squared. Okay, and for a couple more rules here, the next one is negative integers as exponents. So for negative integers as exponents, b to the negative n, if we have a negative exponent, we can rewrite that as a positive exponent by essentially reciprocating the base. It would be 1 over b to the positive n. So something else that'll come in handy here is that it's either that, or it can be, if we have 1 over b to the negative n, that becomes b to the positive n. So getting an idea of why this is, let's say we had b squared over b to the 4th. Okay, so based on the quotient rule, we would subtract, that's b to the 2 minus 4, which is b to the negative 2. Or if we start with that again and do it a different way, that would be b times b in the numerator over b times b times b times b in the denominator. two b's in the numerator and denominator will cancel. We'll be left with 1 over b times b, so 1 over b squared. Since we started with the same thing on both of these and we got two separate answers, these separate answers have to be equal. So that means b to the negative 2 has to equal 1 over b squared. Now let's do some of these examples. So let's use negative exponent rule to rewrite each one of these expressions with a positive exponent. So let's say we have 9 to the negative 2. So based on this rule, it equals 1 over 9 to the positive 2. And I'm just going to leave it like that. I'm not going to write it as 1 over 81. Doesn't matter for the sake of this example. Next one, we have negative 2 to the negative 5. So once again, negative exponent. So it's going to be 1 over negative 2 to the positive 5. Just going to leave it just like that. Next one, 1 over 6 to the negative 2. So in order to make this positive, we're going to plop it in the numerator and make it a positive 2. And for D, 7x to the negative 5 times y squared. The only thing we have to change here is x to the negative 5. So it's going to be 7y squared over x to the positive 5. Okay, and for the next one, a couple more I think, is the power rule for exponents. So the power rule says if we have b to the m, so we already have an exponent on a base, and then we raise it to another power, which is n, b to the m to the n. To combine that, to get rid of those parentheses, we have to multiply those powers. So it's b to the m times n. So if we have a power to a power, we have to multiply. So let's say we had b squared cubed. What this means is we're multiplying b squared together 3 times. So what we would do is we would add those exponents now, right? They're common bases, so we add the exponents. That would be b to the 2 plus 2 plus 2, which is b to the 6th. And that actually just shows that b squared cubed equals b to the 2 times 3, where we multiply the exponents, because 2 times 3 does give us that 6. Okay, let's simplify these using that rule. First one, x cubed and then to the 9th. So as soon as you see a power already raised to another power, we know we're multiplying. So it's going to be x raised up to the 3 times 9, which is x to the 27th. Next one, 2 squared cubed. So power to a power, we multiply. That's going to be 2 raised up to the 2 times 3. So 2 to the 6th. Then we have y to the 5th raised up to the negative 3. Power to a power, we multiply 5 times negative 3. So we get y to the negative 15th. So writing this with a positive exponent, it's going to be 1 over y to the positive 15. Last one, b to the negative 4 and then to the negative 2. Power to a power, multiply. Negative 4 times negative 2. That gives us b to the positive 8. Okay, so I think there's only 2 more rules here, so kind of getting there. The next one's called the product to powers rule for exponent. You don't have to know the name for the rules, just make sure you know how to use them. So we have a, b, so it's a times b to the nth power. You can split that up and give each one of those factors that exponent of n. So a times b to the nth equals a to the nth times b to the nth. So let's say we had 2x cubed. So that means 2 times x to the 3rd. So we can give the 2 an exponent of 3 as well as the x then, based on this rule. Oh, sorry, that's the rule itself. This means that it's 2x times 2x times 2x, 3 times. Oops. So we could rearrange this, right, as 2 times 2 times 2 times x times x times x. And then we could see that it's 2 cubed times x cubed. Because we had the x's grouped up, there was 3 of them, and the 2's grouped up, we had 3 of them, so 2 cubed times x cubed. So we just showed that 2x cubed equals 2 cubed times x cubed, which is exactly what the rule says, so it should make sense. Okay, let's do some examples. So we have 3y squared for the first one. So the whole thing is being raised to that exponent. So this is going to be the same as 3 squared times y squared. So that's going to be 9y squared. Next one, we have negative 2y squared to the fourth. So I'm going to give that negative 2 to the power of 4 with parentheses, as well as that y squared. Negative 2 to the fourth, and a negative to an even power is positive number. It's positive 16. Y squared to the fourth, power to a power, we multiply. 2 times 4 is 8. Next one, 2 times negative 3x is e to the negative 1 cubed. So the 2 is not in those parentheses, so I'm going to leave it out front. And then I'm going to give the negative 3 an exponent of 3. I'm going to give the x an exponent of 3. And I'm going to give the z to the negative 1 an exponent of 3. So it's going to be 2 times negative 3 cubed is negative 27 times x cubed. Z to the negative 1 cubed, that's a power to a power, so we multiply. Z to the negative 3. 2 times negative 27 is negative 54. X cubed. Z to the negative 3 as a positive exponent will become z to the positive 3 in the denominator. Okay, so one more for this one. We have negative and then x squared y cubed z all to the negative 5. Negative is not under the parentheses, so that stays out front. And then we have x squared to the negative 5 times y cubed to the negative 5 times z to the negative 5. So all of these are powers to powers, so we're going to be multiplying. So it's going to be negative x to the negative 10, y to the negative 15, and z to the negative 5. All of those exponents are negative, so to make them positive, we throw them in the denominator. So if we do that, there's going to be a 1 left out front, a 1 left in the numerator. So in the denominator, it's going to be x to the 10th, y to the 15th, and z to the 5th. Okay, so last rule, and then we'll combine them and do extra problems here. So it's called the quotient to power rule for exponents. So it's similar to what we just did, except this time if we're dividing numbers, a divided by b to the power of n, we can give the exponent to the numerator and the denominator. So a over b all to the n equals a to the n over b to the n. So first example, we have x over y to the fourth. So it's a fraction, the whole thing is to an exponent. So we can give the numerator the exponent as well as the denominator. So it equals x to the fourth over y to the fourth. Next one, we have negative and then 2 over y to the second. So I'm actually going to give that negative with the numerator and make it negative 2. So give the exponent to the numerator and denominator separately. Negative 2 squared is positive 4, so it's 4 over y squared. Next, we have x squared over 4 all cubed. So giving the exponent giving the numerator an exponent of 3 as well as the denominator. X squared cubed, power to a power, we multiply and get x to the 6th. And then 4 cubed is 64. Last one here, we have 2x over yz cubed to the negative 6. So a little trick for this one, when you have a fraction to a negative exponent, what you should always do first is you should reciprocate the fraction. So I'm going to make it yz cubed over 2x. When you do that, the exponent of 6 here becomes positive. So negative exponent over a fraction, make it positive by reciprocating that fraction. So now I'm going to give that whole numerator that exponent of 6, and that whole denominator the exponent of 6. So now for that numerator, I need to give both of those factors that exponent, so it's y to the 6th times z cubed to the 6th. We need to give the denominator 2 to the 6th times x to the 6th. So this is going to become y to the 6th times z to the 18th, because it was a power to a power, we multiply. 2 to the 6th, 64, times x to the 6th. Okay, so those are all the rules, kind of a lot, I know, but we definitely have to know them. So this brings us to simplifying these exponential expressions in general. So properties of exponents that we just learned, they're going to be used to simplify these expressions. We consider an exponential expression simplified when the parentheses are gone. No powers are raised to other powers. Each base occurs only once. And there's no negative or zero exponents. So for this first example here, we have, so we're going to simplify all these. We have negative 3x to the 4th, y to the 5th, all raised to the 3rd power. So we have multiple factors being raised to the exponent, so we need to give each one of them an exponent of 3. So we get this. And for evaluating negative 3 cubed, that's negative 27. And then for the variables, x to the 4th cubed, power to a power, we multiply and get x to the 12th. Same thing with y to the 5th cubed, power to a power, we multiply and get y to the 15th. And x1, negative 7x y to the 4th times negative 2 x to the 5th y to the 6th. So we don't have powers to powers or anything, we're just multiplying. So negative 7 times negative 2 is positive 14. X times x to the 5th, that's x to the 1st. So we're adding exponents here. So it's x to the 1 plus 5. And then we're adding exponents for the y. That's y to the 4 plus 6. So this equals 14x to the 6th, y to the 10th. Next one, we have negative 35 x squared y to the 4th over 5x to the 6th y to the negative 8. So negative 35 divided by 5 is 7. So we're dividing here, so we need to subtract exponents. So it's going to be x to the 2 minus 6, and then y to the 4 minus negative 8. So it's going to be 7x to the negative 4, y to the 12th. 4 minus negative 8 is positive 12. And then we have to make the exponent positive on the x, so it's 7y to the 12th divided by x to the positive 4. Okay, I think we have 3 more left here. So 4x squared over y, all to the negative 3. So remember, if you have a fraction to a negative exponent, just reciprocate that fraction and make the exponent positive. So now we have a fraction to an exponent. Let's give the numerator the exponent and the denominator. So it's going to be y cubed over, so in that denominator, 4x squared, we need to give the 4 the exponent, as well as the x squared. And for that, we get y cubed. 4 cubed is 64. X squared cubed, power to a power, we multiply, and we get x to the 6th. So y cubed over 64x to the 6th. Okay, so let's do 2 messy ones here. So we have negative x squared y to the 4th all squared times x cubed y to z to the negative 2 all cubed divided by that whole nasty looking denominator. So we kind of have three chunks here, these three sets of parentheses. So let's take care of each one of those first. So for the first one, I'm not going to show every single step here. I'm just going to kind of say it. So kind of bear with me here. I just don't want it to take up too much room. So for this first one right here, this first set of parentheses in the numerator, that's a -1. I'm going to give that squared to each factor. -1 squared is +1, so that negative is going to go away. X squared to the +2 power to a power, we're going to multiply. That's going to be x to the 4th. And then y to the 4th squared power to a power, we multiply. We get y to the 8th. So that's from that first term. For this second term here, I'm going to give each one of these factors inside the exponent of 3. So x cubed to the 3rd power to a power, we multiply. 3 times 3 is 9. And then that's going to be times y cubed. Z to the -2 cubed is going to be z to the -6. -2 times 3, -6. Okay, so already looking pretty good in the numerator. And then in that denominator, everything is raised to the 4th. So I'm going to give every factor that power of 4. 2 to the 4th is 16. X to the 6th to the 4th, power to a power, we multiply. 6 times 4 is 24. Y to the let me put the highlighter on that so we know I'm doing that. Y to the -8th to the 4th is y to the -32 multiplied -8 times 4. Z to the -1 to the 4th, we multiply -1 times 4, we get -4. So that denominator is almost kind of simplified. We have to still simplify that numerator. We need to combine all of those variables into one base. So we have to do that by adding the exponents, right? So x to the 4th times x to the 9th, 4 plus 9 is 13, so x to the 13th. Y to the 8th times y cubed, we add the exponents, we get y to the 11th. And we only have one z term, that's z to the -6th. Just going to rewrite this denominator. Okay, and then I think two more kind of little steps here. We're dividing, so we need to subtract exponents here. So everything is going to be in the numerator, except we're going to have that 16 still in the denominator. So x to the 13 minus 24. 13 minus 24 is -11. For y, 11 minus -32, that's 11 plus 32, which is 43. For z, -6 minus -4, that's -6 plus 4, which is -2. So what we get here for the final step, we have to make those exponents positive. It's going to be y to the 43 over x to the 16, but 16 first. 16 x to the 11th, z to the +2. And that's the final answer. So kind of messy, but it helps when you can do some of the steps in your head so it doesn't get kind of overcrowded and crazy. Let's do one more. So this one's obviously pretty messy. So the first thing, I'm not even going to bother reading that whole thing off. The first thing that I recognize is there is a negative exponent, right? So I'm going to reciprocate that fraction inside those big parentheses. So I'm going to completely reciprocate it. 5x to the 6th, y to the -8th, z to the -6th. And it's going to be all divided by that numerator. And then hopefully by now you know why I did that. I did it because now all of that is raised to the positive exponent. Just makes it easier to work with. There's always going to be multiple ways to do these problems. I just personally think that's the easiest first step here. Okay, for this numerator, it's already kind of simplified, so I'm going to leave it as is. For the denominator, what I'm going to do is I'm going to take care of those chunks, the parentheses. So for that first parenthesis chunk, we have 2x cubed z squared. So I'm going to square every single one of those without writing it out. So 2 squared is 4. X cubed squared, power to a power, we multiply and get x to the 6th. And then we just have z squared. Next we have the next parentheses raised to the 3rd power in the denominator. So it's -1 cubed. -1 cubed is still -1, so that negative is going to stay put. Then we have x squared cubed, power to a power, we multiply, 2 times 3 is 6. And then we have times y cubed, z to the -1 cubed, -1 times 3 is -3. So all of that is squared. I'm going to take care of the squared thing last. So still have to finish up that denominator, keeping, I didn't even touch that numerator. Okay, so combining that numerator now, it's going to be 4 times -1, so -4. X to the 6th times x to the 6th, that's x to the 12th. We're adding. And then for the y variable, it's just y cubed. There's only one y term down there. And then z squared times z to the -3. We were adding again, so z to the -1. Okay, and now let's simplify with the fraction as a whole here. So we're going to be subtracting exponents. So we're going to have 5. So it's going to be x to the 6th divided by x to the 12th. 6 minus 12 is -6. For the y variable, y to the -8 minus 3. -8 minus 3 is -11. And then for z, it's going to be -6 minus -1. That's -6 plus 1, so that's -5. All of this is still over -4. And it's all still squared. So almost done here, like 2 or 3 more steps. I'm going to give, before I give that exponent to everything, I'm going to make those exponents positive by putting them in the denominator. So it's going to be x to the +6, y to the +11, z to the +5. And now I'm going to use that exponent, and I'm going to square the numerator and denominator. So 5 squared is 25. -4 squared is 16. X to the 6th squared, power to a power we multiply, is going to be x to the 12th. Y to the 11th squared, multiply, 11 times 2 is 22. Z to the 5th squared, 5 times 2 is 10. Okay, so obviously the messiest one out of all of them, but still pretty doable. Take it step at a time and just be careful with your rules. Okay, so that's it for these 2 sections.